Hi, good afternoon. I think we are ready to start the TEAS session in IETF 122. So if you can close the doors back so we don't have any noise coming. So let's wait for the after lunch comers. Okay, perfect. Okay, so here the first thing is one to announce that we have recently a new secretary. So welcome Italo. Well, he's not able to to participate in person this week. I think we had a also a collision with an ITUT meeting, so he could not participate in person anyway. Congratulations for Italo to help us in being secretary. So here you have all the information. So we have our usual not well of the reminders of the IETF policies. So I encourage you to go through it if you haven't done so at this moment. The conduct guidelines, we know that we conduct very heated discussions sometimes. So here, as always, we want to have conversations with respect and courtesy to the colleagues. So even you can comment and keep the discussions impersonal. They are technical. So here we want people to contribute and to keep working and so don't take things personal. Here are some meeting tips. So here for those of you who are here, just don't forget to sign or to log into the applications. Otherwise, we won't get a good spot in the next IDF meetings. Okay? So we will be punished to small rooms, and so please log in. Also, don't forget to log in to come to the queue. And if you are remote, just use headset and turn everything off and be ready. We always have, I don't think this time we have anyone connecting from remote, so here we will have everything on site this time. Here are the links for the session materials, note taking. So here we will appreciate help in the note taking. If there are any volunteers, please help us. Otherwise, I mean, also we can take care of that part later. But any help is required here. So here, this is the agenda that we have today. So first, Pavan will go through the different working group drafts that we have around, and then we will enter into the discussion, into the technical presentations, and we have both working group items and new coming items. Okay, so here we will start with the scalability consideration of NRPs, the ACTN for packet over optical for service assurance, the DCA aware topology model that will present by Luis, the OEM for network source partitioning and segment routing, and then also we have a couple of items, the in-place bandwidth update for SDPT, and finally, I hope some of you might have been to either the site meeting or the talk today. We will have the last part of the multipath traffic engineering, so it's nice to have a lot of traffic engineering mechanism updates in TEAS. So let's move to the document status. So here, congratulations, we have 2 new RFCs being published. So the long queue that we had in TEAS is progressively being relieved. Also here we have 3 documents that we have now in the RFC editor queue. So we hope that for the next ITF meeting we have those ready, and then we have a couple of them in ICB. So if you want.
Hi, Dhruv Huawei. For VN Yang, we are in auth 48. One of our authors we are not able to reach. We need help there.
So this is Igor, right?
Yes.
Give me a couple of days. If we don't hear back from him by the end of the week, we will move him to contributor and
Yeah,
progress.
just wanted the working group to be aware of. Thank you.
Okay. Thank you. So then, as mentioned, we have the NSIP MPLS and the network slice MBI, both of them in the ISG evaluation. So I think they will be in the telechat next month. So we expect a few weeks or a few revisions for those of them. And then we have three documents that have passed the last call, so we are going to handle them, the three of them in a bunch. So we already have Shepherd for the three documents for the RFC 8776 update. This is the T-types update. The T-Young that, well, it's going to be the record of the document that has been taking longer in TEAS, and the path computation. So here, we prefer to go with them in a bunch because the T types, I say, is a little bit the key of the other two, but it's better to have them in a bunch. But as I mentioned, they all have shepherds, so we expect to move them forward. And finally, we still need the update of the L3T topology. This one, we had a comment last IETF or a request to move the specific packet technology-specific packet extensions out. But finally, it was decided to keep it there in the document. So we need the update for the justification and to include it there. So as soon as say that part is clarified and everybody is okay with the keeping those extensions there, then that document can also move forward. Also, we have a couple of documents that were adopted. The NS models applicability that explained how to use the different shared network service young models to build slices, and the network slice topology. So we expect that within the next, at least for next idea, we expect to have contributions for that. Okay, so we'll move forward. So we have a couple of liaisons. So here, I don't know if we have this code around here. So the first one is a request coming from ITUT for us to provide information of the activity related to 5G and beyond. So they want to hear all the progress on NFB, programmable networks, managed network, autonomous network, slicing, etc. So here the request is sent to CCAM, DETNet, DMM, and TEAS. Okay, so here I think we have chairs for, also we have from DETNet, and so here what we will work internally is with the other chairs to coordinate the answer. So here the main intention is to compile all the relevant documents from the four working groups. Other times, what we have done is just to select one champion to collect all the input. So we will have to decide between us or with the help of Scott who takes the lead. Okay, so if CCAM, DETNet. In other parts, the ITU, when it was the SG15, it was usually CCAM because it was more optical, but here it's more broad. So I think this not necessarily need to be CCAM that takes the lead, but I don't see a Scott around, right? Okay, so in case any comment here from the room for this lesson. And then there is another one for the OT&T standardization work plan, and that that's led mainly by CCAM for asking for OT&T standardization work plan. So the point that we will need is more attention is the first one for the ITUT. Okay, so just a reminder of the IPR disclosure. So here we want to make sure that we collect the inputs as soon as possible. So here we collect them when we adopt a working group document and when we go to the last call. Okay, so here what we require is everyone that is listed there to reply. So here we have had some issues in the past with people, with contributors that are not regular IETF attendees, and we had some always issues in getting the answers from them. So just when you incorporate contributors, just make them know that they need to follow this process. Okay? So I think with this we are done, and now this well just remind that you need to provide the status update of the working group documents at every meeting, or if not, just do a small report on the ITF session. So I think we can jump to the session with the detail. I can just share the slide. Yeah. I need to pass the back and stop slide. And I can do it better next time. And you can.
Next on the agenda is the working group document status. Thanks to our new secretary, Italo, for collating all the status reports and putting the slide deck together for us. In recent months, we have also been trying to keep our working group wiki up to date in terms of the chair's notes for each of the working group documents. The wiki also has provides some insights into the various individual documents that are currently under consideration for adoption. So please do take a look at it. If you think there's anything that's misrepresented, reach out to Italo or the chairs and we'll sort it out. So this brings us to my favorite slide in this deck. There are 5 documents that are in the publication requested state. 3 of those are in the RFC 8S queue. A couple of them are still under ISG evaluation. There's one document, the NRP scalability document, that's on the agenda today. So that leaves us with 24 documents. And the status of each of those 24 documents is captured in the slide deck. We have 4 documents in what we call the post-working group last call state. These are documents for which we have finished the last call process, but we haven't yet submitted it to ISG for publication. 3 of those documents don't have any open issues as of today. Thanks to everyone who helped us to bring these 3 documents to the stage. The next step would be for the shepherds to finish the write-ups and take them through to the next stage. There's one document, as Oscar was mentioning earlier, the L3TE topology document, for which there is a pending issue, and the chairs will work with the editor, Shufeng, to get it fixed and take it to the next stage. We also have about 8 documents that are in expired state. Some of those are almost close to a last call. We would like to urge the authors to revive those and work with us to take it to the next stage. There are 2 ACTN specific documents. There's the ACTN performance monitoring telemetry document and also the ACTN POI applicability document that are deemed ready for last call. So please do review those 2 documents in anticipation of a last call. We should be taking them through to the next stage before the next IETF. I will now double click on a select few documents. Documents that we believe need some attention. For the rest of them, go through the slides, go through the wiki, go through the status reports that are sent to the list. And if you have any questions on any of those that I wouldn't be covering, please do either come to the mic or send them to the list and we will answer them. So let me now jump to slide 3. This is the document that talks about the applicability of the IETF network slicing framework for 5G end-to-end network slicing. In the last meeting, we discussed about having a new revision and then reaching out to 3GPP for feedback. A new revision for this was published earlier this month. And I believe it's now the right time to reach out to 3GPP, send a liaison request, and seek feedback. So please do expect to see some liaison text sent to the list for your review, and we'll then take it from there. Any questions on the planned liaison? Okay. So let me jump to slide, I believe it's 8. This is the NRP Young document. There are a couple of major updates. One had to do with aligning the model to the NRP selector specific recommendations that are made on the list. And the second had to do with uh, catering to med suggestion for restructuring the model to allow for device specific NRP policies to be also managed via this model. So please do take a look at the model. If there are any questions or concerns, reach out to the authors on the list. And this is also something that we would like to bundle it together with the other NRP documents. There are 3 NRP documents currently in the working group. So we would like to make sure that these progress together and get submitted to ISG as a bundle. So let me jump to slide 10. This is the document that talks about realizing network slicing in IP MPLS documents using this notion of network resource partitions. Again, the major update here is aligning the text to the NRP selector specific discussion that happened on the list. There was some specific text added with respect to fallback treatment for unclassified packets. This was one aspect that we didn't get too much. I mean, we could have gone either way. There were a couple of responses that said there shouldn't be flexibility in terms of carrying the fallback behavior in the network selector, in the NRP selector identifier. And there were a couple of other responses which wanted the flexibility. The chairs took a call to allow for the flexibility, but this is, if anybody has concerns with this, now would be a good time to raise it and initiate the discussion on the list. Absent any discussion, I think we will go ahead with the recommended option. So those were the documents that we wanted to draw your attention to in this slide deck. There was, okay. Like I mentioned, there are quite a few modeling specific documents that we would like to take to the next stage before the next IETF. So any reviews that you could do, especially the young model documents, those would be greatly appreciated. Any questions on any of the working group documents before we jump to the first presentation? Okay, nobody is rushing to the mic. First presenter is, okay.
Zafar from Cisco. I did go over the email that was sent as a conclusion. I did notice that the sample size is very low for both. It was maybe like timing or something or not, but that's at least my concern with that.
That's understood. I mean, if you have any specific comments, please do make it to the list. The calls were made based on the responses that were sent to the list.
Understood.
Given the sample size, given the responses, we thought we made the right calls. But if there is any reservations about that, yeah, please do bring it to the list.
Understood. Thank you.
Thank you. G.
Okay. Good afternoon, everyone. This is Jaedong from Huawei. I'm going to present this update on the scalability considerations for the NRP on behalf of my co-authors. Okay, a quick recap of this concept, network slicing and NRP. I think people in the room should already very familiar with this concept, so I will be quick. We know that network slice IETF network slice has been described in RFC 9543, and it also introduced a concept called NRP, which consists of a set of network resources, and is associated with a filter topology. And the NRP can be used to support a group of the network slice services. In order to support the widely deployment of network slice service, the scalability of NRP is also important. So this document gives the analysis and the design principles about the scalability of the NRP. And it also proposed some scalability optimization mechanisms in the document. So here are the progress and updates since last IETF. I think Pavan just mentioned that the working group has reached a conclusion on the terminology and also the general design of the dedicated data plane ID for the NRP. So we have this terminology reached to the NRP selector ID. As for the length of the ID, the conclusion is it can be different for different data plane types. And the recommended minimum is 8 bits. And it also mentioned a strict match indicator. This is something nice to have, as it can provide more granular control for the forwarding behavior. And the actual encoding of this indicator can be different for different data plane types. So all these conclusions has been incorporated into the data plane optimization section in this document. And this update also tries to address the comments received on the scalability design principles, mostly about the control plane part. Tariq and Zafar used to express the concern on the change made in the previous 04 version, which changed this thing that it deviates from the working group agreement to not rely on the routing protocols for the per NRP state information distribution. So in this latest version, we have changed the text to address the concerns about carrying the per NRP state in the underlay routing protocols, such as IGP or BGP. So the current text is shown here. I think you can take a look. We think it's reasonable, and it make it clear that underlay routing should not be used for this. And in case they really need to be used, we propose to isolate this information from the underlay routing information to keep the stability and the functionality of this basic underlay routing. And the plan is, if the working group thinks it's useful, we can also elaborate on the design principle on the protocols for the distributed routing and the protocols for the communication with the northbound with the controller. I think because the routing is kind of a broad term, maybe we can separate either one for the distributed control plane and one for the northbound and southbound interaction. Okay, so the next step is we plan to update and this draft if there's any further comments, and we try to reach consensus on the scalability design principles. Then we are ready for the working group last call. Okay? Comments?
Any questions for G?
Zafar from Cisco. Thank you, G, for addressing the comments. You did show, Paul, we did talk about that, the volume below, but I have a different comment. In your draft, you're still asserting that the size of the scale size is in thousands, which is not at least in my knowledge, in terms of the number of NRPs in a network. So maybe we can have some discussion on that. We believe in order of tens, not thousands. It's a transport network. It's 5G. You reference that 5G, but then you do end-to-one mapping. So it's not that many. So because this is a scaling graph, I think it's good to clarify what is the right number.
Yeah. For this part, I think the This draft gives use cases of different scenarios of using network slicing and NRP. Actually, in the early stage, we did mention that the number of the NRP required may be around the tens or at this level, but there are also use cases which require hundreds of or even thousands of. I think we mentioned the different use cases in the draft. If we really need a per application open tenant NRP, that is something we cannot say they are widely deployed, but we see some requirement, and some people are talking about these use cases. So that is why we need this scalability draft. If we only consider tens of NRPs, that is something easy to be achieved. Right.
Yeah, but on the other hand, I think that when you have a scalability draft, it's supposed to guide people that doing one-to-one mapping, it doesn't scale. So anyway, we can talk a bit more offline. The other thing is that there is another working group document, IETF TEAS NSIP MPLS. Would you go to take the two documents more like together towards the last call, or?
So there are still open items with the NSIPM plus document. The expectation is that those will be resolved before Madrid, and then we will look at progressing these together. There may be some text that moves around between the two documents, but we'll make that call when we are done with the other document.
No, thank you. That's what I expected. There is some dependency. Thank you.
Thank you.
Hi, I'm Adrian. I think to Zafar's point, the NRP was introduced in order to achieve the scalability. But as we did the framework document, we were pushed to say an option is to have one slice per NRP. Now, that's not saying we think this is a good choice, but it is a choice. And it's kind of up to the deployment what it does. So I think what G is trying to do in his document is say, these are the scaling properties. And if you make this choice, this is the consequence. So it has to be allowed that it might scale to thousands, but be aware that if you do that, this is what you get.
Yes.
We did have an interim some time back, and we did have some discussion on what the maximum number needs to be, but nobody came up with a number. So that's where we are. So the only recommendation we made is have at least, I think there was a minimum size that was mentioned, and that's what we have.
Okay. Thanks, G. Thank you.
Thank you.
Hello, this is Paolo Huawei, and I'm giving you an update actually on the POI service assurance on behalf of the other people you see on the cover page. So Fabio, Italo, Jean-Francois, Jeff, actually, in the present sheet. So about the scope of the draft, in essence, we expanded the POI applicability draft, taking care of the fault and performance management in a multi-layer and multi-domain network. I think we already discussed in the past during other meetings, the reason why we kept the two documents separated. Basically, it's to avoid to have a single bulky document, which is almost impossible to read. So the POI applicability can be considered as the father document, and we developed all the service assurance part in this specific draft. Clearly, everything is based on the ACTN architecture. So you see listed here, RFC 8453. What is the scope of the draft? As I said, it's basically to take care of the fault management and the performance management in a multi-layer, multi-domain network. When we say multi-layer, it means there is an IP layer over the optical layer, and we have multiple domains, so access, core, and so on. One important detail, it's a kind of, let me say, traditional network. So the interfaces between the IP layer and the optical layer are gray. So we are not taking care of, for example, transponders inserted into a router. So what we have done, let's say, as a difference with regard to the latest release, this is the full history. Basically, we started the work in 2023, so the beginning of 2023. There is the evolution of the different reviews we have done. I would say that most of the work was done between version 3 and version 5, so the current one. Specifically for version 5, I would say we have almost completed the fault related analysis and the performance related analysis. Specifically about the performance management, we also introduced a new section. It's a new case for the measurement of the, for example, SLAs in multiple IP domains. So you see section 6.2, and I'm going to talk about that in the next slide. We have also expanded the discussion on the cross-link failures, meaning the failures occurring between a router and the first optical node in the network. And I would say we also clarified a bit the scope of the section about the analysis of the existing models related to assurance. As I said, most of the work was done. If you go to GitHub and follow the link that is reported at the end at the bottom of the slide, you see that during the last months we have almost closed the remaining open issues. So I would say it was quite a good work we did, and basically the main issues we solved are what we numbered as number 12. You see the failure scenarios. So there was a kind of, let's say, not complete or not full connection with POI applicability. We aligned the text to the, let's say, to the parent document. So we have clearly specified that whenever a fault occurs in the optical network, it's responsibility of the optical controller to give to the parent controller, so the MDSC, the information just right to determine where the fault has happened. And then the MDSC takes all the corrective actions. We also completed one of the use cases requested specifically by Fabio of Telecom Italia. So discussed a potential case that actually is not to be find very often in the field, but actually they were interested into that. So how to realize a kind of N+1 protection scheme, so adding a further port on the router and having the N+1 connection between the router and the optical node, and maybe saving some optical resources in the optical network. And we added some text from Daniel just to explain the potentiality, at least, of this case. And as I said, we completed the performance monitoring section. And we also tried to start an analysis on the IP end-to-end measurement. So consider, for example, 2 domains. And after discussing quite a bit, actually, this potential scenario, we decided to report the case in the draft, but also not to develop that anymore. There is one reason for that. And here, clearly, we can also discuss in the Q&A part. I would say, technically speaking, there is no issue in measuring a performance in an IP network, even if we consider multiple domains. But very often, it happens that we have the concept of limited domain or constrained domain. And when you reach the border of the domain, it's very difficult to, let's say, exchange the performance information between one domain and the other. Or said in different terms, for example, between the organization taking care of domain A and the next organization taking care of domain B. So considering that difficulty, we decided not to go ahead with our analysis, but as I said, just to list the case and see if there is a further interest, maybe by the working group. Said that, considering the issues I've just discussed, and also the scope of section 4 of the document, which is the gap analysis on the existing young models relevant to service assurance, I would say that we have just refined also the scope of that part, saying that section 4, so the gap analysis will be like that, so just a gap analysis. At some point in time, there was a question within the working group whether we should also, in case we identify a real gap, also to develop, let's say, a new model or, let's say, augment an existing one. So the decision was taken to keep the document as it is. So we will try to complete the gap analysis, but in case we find something that needs further work, that will be part of a different draft. One important point, I think here we could need the help from TEAS. I mean, we have started to look at the different models, at the different possibilities that are already available. If you find anything that is missing or should be referenced in the draft, please reach out to us and we would be happy to have, let's say, your opinion. So that next step. We have worked, I would say, quite well to complete the open issues. So as co-authors, we believe that the draft could be adopted by TEAS. So we will, let's say, reach out to the chairs just to ask for their opinion. And as I said, probably the adoption could be also beneficial to have some support from TEAS for the gap analysis. So I think that having the document adopted, that could be, let's say, a kind of commitment for the entire working group. So that we are open to any comments and thanks for the feedback.
Yeah. So my main comment is you had one of the goals of the document is to identify the existing young models, right? So, but you mentioned later that that the gaps were not clear whether they are. You're gonna. So, what is the expected output? That you come. All of these are all the young models, and I have no found or didn't find the young models that complied for these ones, or what is the expected final outcome?
Okay, so let's say that if you go through the different sections of the document, you see all the cases, the failure cases discussed, restoration, protection, whatever the optic and so on. The idea is that we have started this part of the analysis, but we will try to complete by the next IETF. We will try to look at the different models to see that everything which is currently available is enough to support the cases, the failure cases, the performance measurement cases that we have listed in the document, in the draft. Answering to your question, if this is not the case, then we will raise the flag saying, okay, that the bit that is missing in, for example, this specific young model. So that's our scope for the moment, unless clearly we are accepting more feedback from the community.
Yeah, that seems fair. We did do a poll for this last time, and at least our notes say that there was sufficient support for considering it for adoption. So Oscar and I will initiate the process, see where it takes us.
Okay, thank you.
Thank you.
Okay.
Yeah, the next couple of presentations, they probably wouldn't end up in TEAS, but the reason why they're being presented here is because there is some relevance either to work that has been done in the past in TEAS or work that's currently ongoing. So let's hear the presentations and then make a call on what would be a suitable home for these. at least going through these two documents, it doesn't seem like they belong to TEAS at this point.
Hello, everyone. This is Luis from Telefonica. I will present an update on this draft. On behalf of my co-author, Shufeng, also to mention that in previous versions, also John Lee was part of the author list. John is now retired. So basically, the problem statement that we try to address with this document is as follows. So more and more operators are deploying compute capabilities in the network. And it would be interesting to have a combined view of network and network resources, let's say, network capabilities and compute resources altogether. Somehow we try to follow the same approach that follows the draft IETF service function aware topology model. In fact, this was part of the draft in previous versions that was somehow removed and spin off later on. So in terms of how to express the resources, the compute resources, essentially there could be two ways to follow. One could be maybe express those resources in terms of quotas. And there was some initiatives in the industry in the past. For instance, the table that you can see on your right essentially is based on some ideas that were developed between GSMA and Linux Foundation in an initiative that was called Cloud Infrastructure Task Force. And now it's somehow it's not going further. But there will be also ways of expressing in terms of raw resources, as we will show later. So summarizing here, the point will be to understand what are the resources and what are the points of attachment to the network in such a way that we can basically build the topology end-to-end with the network and the compute resources. So the history of the draft, this was presented in a number of ITFs before. In 4 of them, being this the 5th one. So we have provided an update of the models, as I will show later. The draft has been already presented in this Neotech site meeting that goes in the direction of having an interplay between cloud managers and network controllers. And basically, to mention that John was part of this before. So the purpose, as I said, is to build this combined view. The idea would be here to retrieve the information from the cloud managers, typically via the APIs that they offer. There are different solutions in the industry, OpenStack, Kubernetes, and so probably the de facto standard now would be Kubernetes. But basically, the point would be to retrieve the information of any potential solution out there. So moving into the examples of the models that we are including in the document, we review the previous model that was in the previous versions, essentially, that was much more OpenStack-like, so with the idea of hypervisors and so. So clearly that required a refinement, and this is why we produce these new models as examples. So summarizing what could be the kind of information that we could retrieve or we could incorporate into the topology would be resources like CPU, memory, and also the pods, the nodes that will host different applications, different workloads, as well as the resources that are being consumed by these workloads. And other information like namespaces and so that are a little bit much more particular of the specific implementation on the cloud side. So, well, probably this is a little bit reiterative. So, the need for the model is basically to allow to satisfy, let's say, or to optimize the service lifecycle specifically for the service placement task, so that the application, the cloud managers could have a complete view, and also if we combine this with traffic engineering capabilities to understand what could be the expected performance at the time of selecting a given data center, a given edge node in the network. So finishing the presentation, so essentially the objective here would be to request comments from the working group to refine the examples. Nacho identified already some points that require some correction. Prepare a new version for the next IETF, even though there could be the case that if there is progress in the Neotech activity, maybe it could be an option to move there further. And that's all from my side. Thank you.
Any comments for Luz? So the last time you presented here, I believe it was the San Francisco IETF. You're gone?
Oh, you can finish your comment.
Should
I was going to wait until you finished your comment. It's Lou. How are you, do you mind going back to the model for a second? Are you thinking about tying this into network resources at all?
So
I don't see network resources in here. Are you thinking about tying it into network resources?
the number of resources.
To type this to network resources.
Yeah.
Here there is no network.
Yeah, for sure. Here there is no network yet, but the idea would be to link this with the point of attachment to the network. So associate to the node where these resources are behind. So thinking, for instance, in a data center gateway or so to link this with the identifier of the node that allows the reachability of these resources. So certainly the network is not yet here, but the idea would be to create that link. Yeah.
But not to describe the required network resources. So only you're saying you're planning to add an attachment point.
Yeah.
What about the requirements for the application from the network?
But I'm not sure it would fit on here.
Okay, so you're thinking that, all right, so this is going to be limited just to resources that are available.
Yes, because the idea here would be this to be consumed by the cloud managers. So those are the ones that will know the needs of the application. So probably with that knowledge, they will select the proper data center. So no need of expressing the requirements of the application here.
Okay, and what about available network resources? So you're not even going to link it to, so this is the availability side, I get it.
Yep. But that would be part of the linkage with the traffic engineering model. I mean, all that view of the network side.
So will you have a leaf ref from this model into the other model?
I think so. That would be
okay.
The way.
Great, thank you.
Yeah.
So, Lou, do you have any thoughts on what would be a good home for this?
I actually couldn't hear you. I'm sorry.
Do you have any thoughts on what would be a good home for this work?
I'm not sure there is a good home. So if you bring in the network resources, maybe you can say it fits here.
Okay, yes. If we do traffic engineering of those and link it to the resources, might hit here, but I still need to see the traffic engineering part on this.
So I think your question really belongs to the AD.
Okay, but we have the Swami's
No, I had the same question.
we have Italo online that I think he wants to make also a comment. So Italo.
Yes, I have a question on slide number 2. Is the solution applicable only if the network is a T network, or is generically applicable to any type of network?
I would say that it is generically applicable. The reference here to T is basically, this is coming from the previous effort on the draft that is also here in this page, the TEAS satisfaction aware topology model. So, but I think it could be generically applicable to also to non-T networks, probably. Yeah.
Okay, so please, maybe we can make it clear in the next draft update. Thank you.
Okay, thank you, Talo.
Let's discuss offline, see what can be done. Thank you.
Thank you.
Yeah, so, but in any case, I see that there is some interest in the topic. I mean, we have had some discussion, so I will not just rule it out of this by the moment, and I would expect also to see how we link these computing resources to traffic engineering, and then let's see, it makes sense here. So thank you. But I think we have. Yeah, present. Let's 1 second.
Okay, thank you, Charles. I'm online.
Leon, you should be able to. Leon, you should be able to control the slides.
Okay, I can control. Thank you. Hi everyone, this is Li Yan from China Mobile. I'm very glad to talk about the topic of OEM for NRP in segment routing. And during the deployment of the network slicing, we found that there is no mature OEM solution for the slicing network. So we have analyzed the commonly used OEM tools with the aim of using them to monitor NRP resource status and rapidly detect faults. And this draft includes the ping, tracer, and BFD stamp, these four protocols. This slide shows the NRP ability check through the ping protocol. First, the first step, the ping request message needs to carry the NRP information such as the NRP ID, and I have known that the WG has agreed that the latest terminology is the NRP selector ID. Maybe we can update the draft later. And,
Lian, do you want to take questions now or want to take questions later? Because we have Greg on the queue. Okay. Perfect. So please continue.
Okay, you can go ahead.
No, you can go. You can.
Okay. I will continue. And for MPLS network, the request message is the MPLS echo request, and for SRv6 is the SAMPv6 message. And the second step for the forwarding device and the endpoint devices, they need to check the NRP ability. If unavailable, the devices should respond to the NRP resources and available error. And here, for MPLS network, new return codes in MPLS echo reply should be registered in INR. And for SR6, it's the SMPv6 reply error code. And if the NRP resource is available, the message should be processed according to the current workflow without any change required. Here, I would like to mention that regarding the method of the carrying of the NRP selector ID, there are already multiple drafts currently under discussion. So this draft, we do not focus on the specific method of carrying the NRP selector ID. And for the tracer process, it's similar. I will not describe it in detail. And what I want to mention is that we also need to carry the NRP selector ID in the request message, and the forwarding device check if it's available or not. Also, a new error code needs to be registered. For the BFD, it's also similar, but the difference lies in the fact that if it is unavailable, so the no response, this station will be filled. And if it is available, there should be some replies for the detection response. So this is the different with the ping and tracer protocol. And FD.
Leon, Greg has a question.
Okay.
Yes.
Go ahead.
Please go ahead.
Hi. Yes, thank you for this work, actually. I shared my comment on the list, and I think that this is very timely work that really fills the gap. The question I have is the benefits of using BFD or STAMP for troubleshooting NRP selector, so consistency of NRP selector programming in a data plane. I agree that use echo request, echo reply, like ICMP and LSP ping is reasonable, and it's really corresponds to how these methods, whether it's ping or traceroute, been used for finding the problem and then localizing and troubleshooting. But it's not really what BFD or STAMP being designed for. And I think that if someone wants to be monitoring consistency of NRP, then I would imagine that the same rules as you describe or prescribe to BFD or STAMP would be applicable to data traffic. Because if we imagine that the data traffic encapsulated with the NRP selector ID, which is not known in the network, then why wouldn't it generate the same message as suggested for ICMP with the NRP is not known? The problem I see here is that because that needs to be processed in a control plane, so then it can be used as an attack vector by sending packets with their misprogrammed NRP selector that will cause a lot of messages. So I would say that it will be okay, seems to be reasonable if these packets will be dropped. And then if the problem, because BFD session would not come up, then operator can use appropriate tools to do the troubleshooting and localize the problem.
Thank you, Greg. I understand your comments, and I want to add some addition for this problem is that for the BFD, we didn't have any extension. We just add the NRP resource ability check. You know, in current flow, there is no check about the NRP resource. We just forward the BFD packet or reply it. But now we must check it along the path for the forwarding devices. And this is one point. And the second point about maybe later on the next page, I will elaborate is about the road. The round trip. We also didn't extend the BFG, and because we have known that there are many drafts which are related to the BFD in SRv6 or the BFD backup path, return path. So I think that maybe for BFD protocol, it can be done on the control plane. It's not necessary to extend it in the data plane. So this point, I think we are on the have the same opinion. So hope it helps you understand this draft.
Well, again, maybe we can take it to the list discussion, because my concern is that you have a reference in this slide to some packet type BFD reply, which I'm not really familiar, because BFD doesn't have a request reply messages. But
Yeah,
let's take it to the list.
Okay, no problem. Move to the list.
Yeah, let's take it to the list. I think, Leon, you're also out of time. So can you summarize? And I mean, this is related to NRPs. This is necessary work, but it's not, TEAS wouldn't be the right home for this. You need to keep TEAS abreast of what's going on, but we'll work with you offline and figure out where this needs to be, where this needs to go.
Okay, thank you. I will be very quick for the rest. So there is another thing we must confirm is that for the round trip pass, I have mentioned previously that we have extend the ping and the trace route and the stamp, which the protocol has defined, already defined the return path. And in this situation, we also adapt the NRP selector ID with the return path. So this is another point of this draft. We extend the protocol message to carry the NRP ID of the return path. And this is the extend error code. We are very familiar with it. Yeah.
Jay, can you keep it quick? We have one more question, and yeah.
Okay, please.
Yeah, Jidong from Huawei. Yeah, actually, I want to understand how the ping and stamp, whether ping and stamp are used to check the availability of the NRP per hop, or it's just to check the availability on the egress node.
Per hop along the path. Yeah.
But ping and the stamp are only processed on the egress. If there's no resource available on the transit node, how can it respond with a ping or stamp message?
Take that question to the list.
Okay.
Leon, thank you. We are moving to the next presentation. Thank you.
Okay, thank you. Thank you.
Hi, my name is Zafar Ali from Cisco. I'm going to present this draft on behalf of my co-authors. Thank you. So let's start with the background and problem statement. So section 2.5 of RFC 3209 describe that if you have to increase the bandwidth of an LSP, then you use make before break procedure. So why we are here is that there are a lot of cases in high scale RSCP deployment where because of auto bandwidth feature, the bandwidth increase and decrease is a very frequent phenomenon. So the point for this draft is to reduce the churn in the network in terms of number of states. And to understand that first, let's see what is in-place bandwidth update really means. And then we go and connect it with how we respect what is in 3209 is written. So in-place bandwidth, let's take a successful sequence. And this sequence is done with the bandwidth decrease use case. So you have routers, R1, R5, and R1 is sending a path message. And there is a state in the network, which is for LSP X. So in place means that you send a path change with LSP X. So use the same LSP. But here, by design for successful sequence, we choose value for the bandwidth decrease case. So the initial bandwidth that was committed is 60 gig, and now the requested bandwidth is 40. The point to note is that the LSP, which is the in-place bandwidth update message, is going with the same LSP instance and same LSP ID. In make before break cases, you always have a different LSP instance and different LSP ID. That's how the make before break works. Because here is using the same LSP ID, and the reason is to try to reduce the number of states. A success of in-place bandwidth update would be that when a message is sent, let's say with TSPEC 40 in path, the reservation come back with flow spec value set to 40. At that time, the ingress knows that the in-place update that it tried to push to the network is successful. Otherwise, it will consider it as a failure. So let's also, like I mentioned, there are certain advantages here. One is that you're not creating a new LSP instance, so not new LSP instance, and then you don't have to program the LSP state in the hardware, like if you were to do make before break. But now coming back to why 3209 was like this for bandwidth update case, is because this message can fail. So this process can fail. And then this is an example of a fail scenario. Again, same example, but in here, instead of picking the bandwidth value to be decreased, we pick the bandwidth value to be increased from 60 to 80. And while the admission at R2 is successful, but it failed at R3. So that's a failed case. We're going to see different iteration why a network may fail in place bandwidth a little bit later. So what we are proposing is again respecting 3209. So the default is make before break, but we can have an ingress LSR, LER, with a configuration that in-place bandwidth is supported. And in that case, if an ingress LSR has in-place bandwidth features configured, it then, whenever there is a bandwidth change, whether increase or decrease, it computes or actually increase, because compute will be needed for increase, for sure. So if there is a need for bandwidth increase, it will compute and check if the current LSP instance can have the new bandwidth using the topology information it is locally available. And if it can, then it basically go ahead with the signaling. But if it cannot, then it falls back to make before break. If it can, it sees that I can all the links around the network have enough bandwidth, then it send the message, and if it's signaling successful, and remember, signaling successful means you get a RSV with the flow spec matching the T spec. Then there is no need to do a make before break procedure. If there is a failure in the signaling process, then fallback is make before break. So a non-ingress node, which is a transit node, is simple. It performs the admission control. So it needs to allow that, okay, I can process the bandwidth increase on incoming on my existing LSP states. And if I have enough bandwidth, I will admit and process the path message to the next hop. And if the bandwidth admission fails, then basically I'm going to send a non-destructive path error towards the head end. Okay. Now let's talk about backward compatibility, because in this in-place bandwidth case, there are three types of failure that can happen. One is that the node doesn't expect that you're going to do this bandwidth change update and will tear down the LSP. B is that it basically says fine, but it sends a path error, an appropriate path error to the ingress. And the C is that it ignores this path message and doesn't respond. So in case of A, we do not recommend that customers should deploy this feature. Customer should use make before break. In case of B or C, this feature could be enabled on non-compliant node, because remember again, fallback, if there's a non-destructive path error comes in or timeout for signaling, then the fallback is make before break. Now, we have a question for the working group, and that is for this feature, when there is a failure in a compliant transit node, should the compliant transit node, which is the new code, use existing admission control failure 1 and bandwidth available subcode 2, or define a new error code, not new error code, admission control failure error code, but subcode to be new, which could be in place bandwidth update failure. I have an opinion that it should be a new, and that is because it helps with debuggability. 2 is that, remember, fallback in the network is make before break. So if a customer deploys this feature and see a lot of in-place bandwidth update failure, this is an indication that the feature is not suitable for this network and is not behaving. So the customer can look at this and actually disable the feature using that. So that's the personal opinion. But with that, let's go with the queue.
Pawan Biram, Juniper Networks, speaking as a co-author. So this is a shipping feature for us. It's been deployed in large auto bandwidth networks where there is frequent churn in the network. Like Zafar was saying, we couldn't agree on this question here. I mean, for us, we just use this existing error code, error value, just because the procedure, the ingress doesn't change. Zafar obviously has a different opinion. So any input on that would be greatly appreciated. I mean, we don't need to get an answer here, but if you can send it to the list, that would be great. Lou, next.
So the ability to signal in place for lower bandwidth has been there in the original 3209. So I'm trying to understand what problem you're solving. And there was a problem, there was an ambiguity in errors that when you got an error, whether it was, I forget the word, but it was whether it's destructive or not. And that was fixed quite a while ago. And that was an update to 3209, which means we should presume that everyone is implementing that now. And if they're not, and they have an issue, their answer is go do that, because we already fixed that problem. So I'm trying to understand what problem we're fixing here. And it sounds to me that you have an implementation problem. And if it's an implementation problem, at best you have an informational document that explains how to go use our existing RFCs. You know, am I missing something here? Is it more than just an implementation problem?
So basically, first of all, it's not for the bandwidth decrease, but bandwidth increase case. And secondly is that if you...
I'm sorry.
It's for bandwidth increase.
But there's already procedures for that, which is make before break.
Yes, but it's basically saying before you, instead of doing make before break, you do bandwidth in place modification for those. So this is not about decrease, it's about increase.
For both.
Okay.
So 3209 always talked about using MBB for bandwidth increase.
Right.
For bandwidth decrease, there was always room for doing in place. That's understood. What we are advocating is try and do in place even for increase if it's possible, even in scenarios where bandwidth is being raised if possible. The only thing that's not unspecified in standards is what should a transit do when it receives an in-place bandwidth request and it cannot accommodate it. That's unspecified in standard documents.
Right, it's based on the node implementation. Sometimes if you're doing an increase, you've already released the bandwidth, so you can't just revert. So that I'll have to go look at what spec is there, but that's part of the in place versus removed on path error was to allow for that. And I don't remember if the text is in there talking about this specific one. You think it's there? You nodded yes, so I'm not sure what
So-
that meant. Well, Pavan, what did you mean by nodding?
No, I meant to say, let's take it to this. I agree with you. It's, we weren't planning on, I mean, like I said, it's a shipping feature. We didn't see the need to standardize it. But obviously, there are implementations out there that do not handle in-place requests coming in. So this is an attempt to fix that and take.
Yeah, it was left as an implementation choice previously. So you're trying to say you don't want that implementation choice.
Just
anymore.
in order to give
I
time for the last
think
presentation.
I would say that, and you are the author of 3209. 3209 only talks use make before break when you have to do a bandwidth update. Because if you look at this this picture, if you do in-place bandwidth, then R2 becomes an inconsistent state because R2 did the admission, it didn't fail on R2, but it failed on R3.
Right.
Okay.
So, can we continue then the discussion, Elise, because we are just having for the last slot, and that was just to give time for Himasu to make a quick comment. I think he was on the queue.
Thank you.
Yes, I'll make a quick comment. I think the same thing. We have a shipping product and been deployed with using the same. For us, there was no need to have a specific uh, configuration to say that we will enable the in-place update. It is always done by default, in-place update first. If it only failed, we would do make before break for increase and decrease. So it works. It's been there for a long time.
Thanks, Himanshu. We'll discuss, obviously, discuss this on the list. Thanks,
Thank you.
Safar. Yeah.
Thank you.
Hey, everyone. How many of you have read the draft MPTEs? Cool. How many of you came to the site meeting? Okay, I can leave now. No. So I'm going to summarize. I mean, this is the first time we're presenting this. So basically, I'll give you a quick overview of what's going on and then a quick overview of what we plan to do with this. So the first thing is that you had this dichotomy between do I do ECMP, which is very nice in its own way, or do I do TE? And essentially, if you do TE, you get a single path. And so all the terminology like label switch path and all the wording in RSC 2702 is around the notion of a path. So the question is, can we generalize that in a good way? So the first thing I want to do is generalize it with ECMP. So you have from the ingress to the egress, all shortest paths that satisfy the constraints. And because you're doing constraints, you get a few fewer paths than you would get with normal ECMP, because you have to fail a link because it doesn't match the color that you want or something. So one way of recovering a few of those paths that you lost is to say, it doesn't have to be shortest path. What if it's shortest path plus 50? And so, or whatever number. And that allows you to do a few more paths. So that's nice. The other thing is we've also been stuck with the idea of a single ingress and a single egress. And so what if we generalize those? And multi-egress is actually a very common use case where you have either IBGP tie-breaking, IBGP multipath, or you have a dual-homed situation for a VPN. And multi-ingress also is useful for a dual home situation for a VPN. So we no longer have to think in terms of one ingress going to one egress over one path. We can have multi-egresses, and lots of paths in between. One very big thing is when you're doing the ECMP or the load balancing, it doesn't have to be equally weighted. And so in order to find what the right weights are, you'd have to do an auxiliary computation. But once you decide that, you can send a message to that node saying, I'd like you to take the traffic that's coming in into the node for this particular DAG, for this particular MPTE, and divide it in this ratio. As a sort of a side comment, I started doing this for MPLS. I did add some IP tunnels. IP tunnels are a little bit more of a challenge, but they're definitely possible. And given that, you can use in many cases IP tunnels. Okay, so I've drawn a few networks here. These networks were shown. I think these are the ones that are shown in the draft. And I did some computations over them, and it illustrates a few things, like if I just have shortest paths, then how many paths do I get? I mean, this is just a basic network with the colors. And then if I do shortest path, how many do I get? If I allow ECMP, I get more, of course. And then if I allow slack, and this is sort of a reason why, or a justification for slack. If slack is measuring fiber miles or delay, does it really matter if you have a 300 millisecond delay or a 310 millisecond delay? So if you do add slack, then you get more paths. One of the things, as I was doing all this, is I came to the realization that more paths is not really what I want. I want more outgoing next hops at more nodes. So if I have a situation where I have, and I literally have run this on networks where uint32 was not big enough to count how many paths there are, but you have maybe a couple of nodes where you only have an outgoing of 2. It's like, okay, that, or maybe just 1, then you have a different problem. So I do talk a lot about more paths, but really we should talk about a metric for sort of the goodness of ECMP should be maybe the min outgoing links across your DAG. Anyway, that's a whole separate thing. So it does use TE constraints. So all the ones you're familiar with include, exclude, SRLGs, bandwidth, protection paths, and so on. And this is just an illustration of how a multi-egress would be interesting. So in this case, nodes 5 and 8 are egresses. The previous example, I was just using 5 as an egress. And so maybe 5 and 8 are both advertising some BGP routes to you. And when you do the tie break, they're equal in everything except the loopback address, and we can turn that off. There's a knob. So then you could use, instead of having 2 independent LSPs to 1 to 5, 1 to 8, you can have a DAG that goes to 5 and 8, and then you just drop your BGP traffic on that, and you don't care where it goes. So the key notion here is this MPTE DAG, which allows you to have multi-path across the network. And it's broken up into a junction. So a junction has a node, P hops and N hops. An ingress would have 0 P hops. An egress would have 0 N hops. You can have a few, if you go back to the P2MP terminology, they call them bud nodes, where you can be an ingress as well as a transit, or you can be an egress as well as a transit. So this is the junction. And then if you focus here, you'll see that node 4 is a junction. It's got 2 coming in and 2 going out. And it would have corresponding labels. So these labels would come in, those labels would go out. One very big question for me was, how do I signal this? I know the kind of things that we've had in trying to signal TE LSPs with RSVP. And there have been some issues. I think we've gotten over many of them, but I was thinking maybe I want to go to something that's BGP based so that I don't have refresh. The details of the protocol don't really matter at this point. The 2 considerations I want for the protocol, I want to write down a list of things that I want the protocol to, features that it should give us. And the second thing is, how do I get that deployed? Both deployed as just a new protocol in the network would be hard, but also deployed incrementally where not all the nodes know MPTE. So those are my main considerations. So the parts here that talk about protocol, for the moment, ignore them. I think we need to have a little more of a discussion on what is the right protocol to use. And then given a particular protocol, how does it measure up against being deployed and being deployed incrementally? So I'm going to skip these slides. They're interesting from the point of view of what is the interesting information to carry, but the way that information is carried in different protocols could be different. So it's another example of something. So the questions are, if I have multi-egress, I think it's a useful case, but is it useful to have one of the egresses also be a transit? So I don't know if I can show you, and I don't want to do this. So if I were to go all the way across the network to an egress, is it interesting that at that point I say, no, I'll hop over to the other egress and then get out of the network? And talking to a couple of service providers, they said, by and large, no. But it might be interesting in the case where the original egress I got to lost its link with its peer, or the link with the peer is congested. So then you can hop over to the other guy. The other question, I think we talked a little bit about it. Should we do a new protocol? Should it be BGP with a new AFI-SAFI? And so on. So that's a discussion we can come back to. I think I need to articulate what characteristics do we want from that protocol. And then the last is slack. So how do you want to measure slack? Is it a percentage? Do you mind going, and this is more a question for operators. Do you mind if a particular path had a slightly longer path length, which could be fiber miles, could be latency, could be something else? So the people I've talked to so far are like, okay, but they want a bound on the slack. But is that bound a percentage bound? Is that an absolute bound? Those are questions to answer. So the next steps, so we have a question, but let me just finish this. I mumble about graceful restart. By mumble, I mean there's a section titled graceful restart, and that's it. I mumble about fib updates. I do have a little bit of information about IP tunnels, but I think we need to go back and put more material there. For the graceful restart, we have done that with many protocols. The nice thing here is we can put it in from the get-go. For fib updates, I think that's important just so that we understand. And then for IP tunnels, I classify the tunnels. So one thing is to see if my classification is correct. And the second thing is, are there IP tunnels I missed? I think a Yang model for this would be really interesting. I already talked about more thinking about the signaling protocol. And then a few questions came by in the side meeting as well as offline. Do we need a PSEP style provisioning of this? And I think PSEP style provisioning is great when you have a controller doing this. In principle, a router can do this as well. But a distributed style like we do with RSVP-TE is also interesting. So I think I would like to pursue a distributed style signaling where routers can set up these MPTE DAGs, and then we can also have a PCE style signaling, and that will come in the future.
Andrea, 1 minute.
Just a quick comment about the Slack. I think it's nice to keep it, and even when you're mentioning about the terms about the DAG is a result of a CSPF output, I think I would actually drop the CSPF term, because when you're invoking Slack, it's not actually in shortest path first, right? And so I would actually, it's a result of a computation. So because of that, if you do have Slack, I actually see that as being a property of the thing that's doing the computation. So I don't know if that actually needs to be standardized. I think, right, different implementations can have different ways of computing their Slack, just like, so it's definitely worth describing the concept of Slack and the fact that you can be non-ECMP. but between, how do you bound it, whether it's a percentage threshold or a differential, whatever, we can describe them, but I don't know if you actually need to standardize that. So,
Yeah,
thanks.
no, you're right. And we typically don't standardize the algorithms. So, it's a good point. So we'll just put in a description and then leave it at that and say, hey, there could be value to this. Implementers may decide to do this, and operators can ask for this, but we don't standardize it. So I agree with you. Yeah, so that's pretty much it. There's a lot of work to do. So I will continue working on the draft, but thank you for giving me the time.
Thanks, Kirti. For those of you who were not there at the site meeting, I understand there's a lot to unpack in a 10-minute slot, but keep looking at the space. There'll be more. Thank you.
Okay. Yeah.
Thank you very much, and looking forward to see you in Madrid again with hot weather. So you need to. Do we need to do anything here now, or just leave room, or just to stop this? Log off and shut off. I think it was a good session. I think it's good to have the good session. Good session.
Now I will check it now.
Yes.